Hello, this is Ananya, and today we will be starting off with simple data structures in Python. Now we have learned the inbuilt data structures such as lists, tuples, sets and dictionaries, right? Now it's time to build our own. So we'll be covering simple topics such as searching and sorting. And firstly, before you get on with sorting, you need to know how to search for a certain element. Now what is searching? Let's see, you have 100 chocolates, okay? And you were to find a certain chocolate of a certain name from those 100. How would you do that? You would obviously use your brain and your eyes and you would find it, right? But the computer can't do that, you know. You have to tell the computer how to find a certain element and how to go about it, and that's the algorithm that we will be learning today. So our first most simple type of search is known as linear search. So we will be learning linear search today. So let's take an example that we have a list of elements. Now consider this list as something like an array, and the user inputs certain elements, okay? And this is your array or list, whatever you want to call it. And you have random numbers inside it, whatever the user inputs. Let's say 7, 23, 9, 1, 100, then 5, 7, 2, just anything, okay? Does not matter. And let's lastly take 99. Now you have these, let's say 1, 2, 3, 4, 5, 6, 7, 8, right? 8 numbers in here. And what you want to do is you want to find the element, let's say 572, okay? So to find 572. Now how will you do that in the case of linear search? What linear does is it goes and checks each and every element from left to right, okay? So let's take an example that we have a variable I to denote the position of each element. So in this case, I is 0, 1, 2, 3, 4, 5, 6 and 7. Alright, so 8 elements altogether. Now what linear search does is, it starts from the element 0, that is at position 0, and goes right up to the end. Now how will you do that? So what you do is start from the element 0. You have your key in mind, okay, that is to find 572. So you start from the 0th position. Did you find it here? No, 572 is not equal to 7. So move ahead. Next, 23 does not match. Move ahead. 9 not equal to. Move ahead. 1 not equal to, again move ahead. 100 no. And then when it comes at position 5, it checks the element at position 5 and the key to be found, that is 572. Both of them match, right? And hence you say that yes, your element is found. And you can say the position at which it was found, that was position 5. Pretty simple, right? Now linear search, you can say it's one of the most simple, okay? All you do is you just keep going from left to right and travel through all the elements. And another thing, if you have noticed, is that it takes a lot of time, right? What if you had 100 elements and you had to find, let's say, the 50th position, or maybe say the 100th position your key is actually situated, and you were to find that. How long would that take? And hence, though it is the most simple one, it is not the most convenient one. But to get started with and wrap your head around the concept of searching, we'll be starting with linear search. Now let's see the implementation of this pretty soon. Alright, now that we have seen the conceptual idea of linear search, let's get to the coding part. As I mentioned, you have an array or a list of numbers. Now make sure the data type has to be exactly the same, okay? And you have a key, whatever you need to find. Let's say, as according to our example, we have 572. Also, we had to take the entire length. We have to traverse the entire length. So you need to know the length of the list or array, right? For that, what you do is you simply take a variable and store the length of the array inside it. And now what I'm going to do is store the returned value of the linear function into result. Now, what does linear exactly take? It takes the array itself, the length of the array, and the key. That is, what number do you want to find? Also try and make this code a little more user-friendly by taking inputs from the user regarding the array list and the keys also, just to make it more dynamic. And inside the linear function, what we have is, remember again, we have to traverse the entire list. So up to n, take it inside a for loop, and if the array of I, remember we had also taken the ith positions to check. So if array of I is equal to key, so in the first case, if I of 0, that is array of 0, 7 is equal to the key, which is not. That is not equal to 572, and hence it'll just skip it and keep running inside the for loop. Now what if 572 wasn't present inside the entire list? What would you do then? You'd simply return false, and hence we have this statement outside the scope of the for loop. Pretty simple, right? Linear search is pretty simple. And that's it. If result is false, you say that it's not present. Otherwise, you say that yes, it is present, and you also provide which position it is at. So in this case, 572 will be at position 5, right? And that's it. That's basically all you have to do for linear search. But only thing that you need to keep in mind is that linear search is very time consuming, okay? Because as I said, imagine you had to go through 100 or 1,000 elements to find a certain, let's say, element, and what if the element was exactly at the last position, that at the 1,000th position? How long do you think that would take? That's the worst case possible. And hence the time complexity here is too much. And hence linear search is not considered as a very approachable, searching algorithm. And hence obviously there are way better algorithms than linear search, but just to get started, right, we are looking at it. And as you can see on the screen, element is present at index 5, and let's give some input that is not present here. Let's say 10. Okay, and it should be giving us the statement that it's not present, and hence there you go, it's not present. Pretty simple, right? I'll meet you all next time again with another better searching algorithm. Till then, bye bye.